And we're back, AP Calc AB students, with the second part of our final video that covers topic 1.5. We're looking at the limits of composite functions with our example 4. We're going to look at parts E through H. Let's give these a try. Once again, I apologize. The graphs are a little hard to read here, so I'll help you through, especially the graph of F that's got these teeny tiny little ordered pairs. So when you look at part E, you see that yes, indeed, we have a composite function, the limit of g of 1 minus f of x. And so what we're supposed to do is take that limit and try to push it through the outside function. And so we would have g of the limit as x approaches 6 from the left of 1 minus f of x. So that's what we're faced with right here to start things off. And so we look at that inside function and we kind of think back to a couple of properties that we had. And it said that we could really think of this as being the limit as x approaches 6 from the left of 1 minus the limit as x approaches 6 from the left of f of x. Now, we haven't formally declared that the limit of a constant is a constant. I do that at the beginning of topic 1.6, but it's likely that you've investigated graphs of some horizontal lines and have come to that realization. And so I don't think it's too far-fetched to think that that limit's going to be 1. Now, for the limit of f as x approaches 6 from the left, once again, here is our good friend 6. And if we think about approaching from the left side, we're moving from this point over, and we find that we're going to arrive at a y value of positive 1. Now, the problem with that is that, yes, that's going to subtract and give us 0, which doesn't seem to be a big issue. And we could go ahead and do that. Maybe we don't have to think about how is it that we are approaching that 1. Let's just say that it's 0. And that's perfectly okay to do that, as long as the outer function g is continuous at 0. And if we go to the graph of g and we look at 0, we find out that yes, we are nice and continuous there. In fact, the answer is going to be -2. And so it's perfectly okay to think of this as g of 0. And of course, that gives us the answer of -2. But if you dived into this a little further and thought, well, wait a minute, how is it that we really did approach that 1? Well, we approached it from above, right? Numbers that are larger than 1. And so if you take 1 minus some numbers that are slightly larger than 1, you're actually going to still approach 0 for numbers that are very close to 1, but you're going to do so from the negative side. And it wouldn't have mattered if we had just approached this from the negative side, because you still get -2. And that's the whole idea of making sure that that outside function is continuous. Now, this is about the only problem that we're going to see here that may have that continuity still intact for the outer function. Let's see if that happens anywhere else. So for problem F, we have a limit as x approaches 3 from the right of f of 15 minus x squared. Once again, not a secret, you're going to push that limit through like this, and you're going to now focus on finding the limit of this very interesting inside function, 15 minus x squared. Now that function doesn't exist up there in our graphs, but you could envision that function in your head or actually put it on paper. In fact, I'm going to write it just right below. I'm going to draw a little sketch of that function. 15 minus x squared. What do we know about that function? Well, hopefully we know that it would have a y-intercept of 15, because when you let x be 0. Hopefully you know a little bit about the fact that it is a parabola, right? It's a quadratic function. It's got a negative leading coefficient. And so it's going to be a parabola shape that looks maybe a little something like this, perhaps. I'm not going to worry so much about scaling out the x and y axis. I also realize that my focus is on what happens when x approaches 3. And when we kind of trace up to this graph, when we get to that x value of 3, there is a y value that's going to exist there. We're only going to approach the 3 from the right side, but it really doesn't matter, because any way that you think about it, you're going to get a 9. Now, wait a minute. How did I get that 9? Well, you're going to start to see some very easy analytic functions coming up in the next topic. And if you've got a very nice continuous function here, when you're finding the limit, you can actually just take your x and plug it directly in for the x in your problem. So 15 minus 3 squared is 15 minus 9, which is not 9, but 6. You see, I was just seeing if you're all paying attention. That should be a 6. The 3 squared is the 9. Subtract it from 15 is 6. Hopefully that makes sense. This is the ordered pair 3, 6. Now, what does that all mean? Well, this is 6, but how does that play out for the outer function? Well, remember our outer function, it was a hot mess at 6, and therefore we can't just apply f of 6 to our answer. We have to think about how is it that we approach this 6 in the first place. So if you look back at this picture, when we were moving up this little part of the parabola, we were approaching this 6 from the underside, 5, 5.5, 5.9, 5.99, and so that would look something like that. And therefore, this will be the limit that we will use to find our outer function. Hopefully that makes sense. And we can move over to our picture. We approach 6 from the left side, and we get that value 1. All right, let's take a look at our parts G and H now. In part G, we have a limit as x approaches 2 from the left of g of 2 minus x squared. Now, if you want to challenge yourself, maybe you ought to pause the video. See if you can solve this. It's very similar to what we did in part F, and you can check back by resuming the video to see if you're correct. Now, I'm going to begin the problem the same way that we always do, by pushing that outer limit through, and then we have something like this. We become very interested now in finding out what is that inside function. 2 minus x squared is a somewhat recognizable function. It's one that you could likely put together here pretty easily. And so we know that it's an upside down parabola once again. It's going to look a little something like this, perhaps. And as I let x approach 2, now one thing I know about this problem is that my 2, if you really want to graph this correctly, is going to be somewhere right there. Because if you enter 2 for x, you get 2 minus 4, which is negative 2. And so what that means is that you've got this place right about here that's going to be the answer to that limit. All of this is undoubtedly going to be negative 2. But there's a little problem with that. Let's extend the page here. There's a little problem with that. Why is that a problem? Well, if you go to the outer function g and you look over here at negative 2, again, it's kind of a mess. We have this discontinuity happening. So I need to answer another question here about this negative 2. How did I approach that negative 2? Well, I was approaching the positive 2 from the left side, so that means I had to be on this part of the graph, traveling this way, on my way to the y value of negative 2. Notice I was doing that from above, passing by numbers like 0 and negative 1 and negative 1.5 and negative 1.99999. And so I actually was getting close to this negative 2 from the above side, which is going to translate to the right side when we take the limit of the outer function. Hopefully this above and below is starting to make sense. Above translates to the right side, below will translate to the left side. So if we go back up to g of x, we approach negative 2 from the right side. That would be along this path, and we get a y value equal to 0, and that's the answer to that limit. Let's finish up with our part H. Once again, we're going to slide the limit function through. I encourage you, if you want to pause the video at this point, give part H a try all on your own and then resume the video to check your answer. In part H, notice we're dealing back with our good friends, the functions that were given, and one of our good friends at least, just the f of x graph. So let's approach -2 from the left. So here's our -2, approach from the left. That's going to be down on this part, and we get this y value that I know is very difficult to see right there. That is indeed -2. And so all of this is -2. Well, guess what? We can't evaluate the function f at -2 because he is very discontinuous. And so instead, we have to rethink, how did we approach that -2? Well, we were coming in from this side as we were getting close to the x value of -2, but to get to the y value of -2, we're doing so from above. And above translates to the plus. That's what we're approaching. And now we set up our outer function as we have up to this point, and we find out that we're really approaching -2 from the right side of the graph of f, which puts us up here and takes us to this y value. Again, hard to see, but that's going to be a +3. And that is the last of our very tricky composite limits. Very difficult. Hang in there with them. Keep practicing. My students, you have a skill builder that you can work on. You have an activity called the odd limit out that can really enhance your understanding of this. The more of these that you do, the more comfortable you're going to get. Hope this helps. We'll see you next time.